Today I'm going to be working on Leetcode question number 331. Verify pre-order serialization of a binary tree. So one way to serialize a binary tree is to use pre-order traversal. When we encounter a non-null node, we record the node's value. So if it is a null node, we record using a sentinel sentinel value such as hash. So basically he's going to be providing us a string or a comma separated characters in a string, and either they're going to be numbers or hash representing a null value. And in the end we're going to look into it and see if it is a valid representation of the binary tree. So an example where it would be false would be one hash, and the reason for that is that we need to have, if there is only one node in it, it needed to have two hashes, so that because that's the proper representation. This is also false 9 hash hash 1, because once we declare that 9 has two childs which are both uh, null, we cannot have another node in that tree. So for this one, what we're going to be doing is basically looking at a node and calculating basically calculating how many are the out degrees and an in degree for that, for every node. So for every node which is not null, you will have two out degrees, meaning you will have two children's, and one in degree, which means that one parent except the root. So in that being said, we're gonna start our difference with 1, because the root is gonna have only uh, one basically it's not gonna have any parent. So we're gonna start with 1, and before even doing that, we need to split our string. So let's just call it the nodes, and we're gonna take this pre-order dot split using a comma. So we're gonna go through all the strings, right, in this, which are gonna be represented as node, like as node, yes. So we're gonna go through it, and every single time we're gonna decrement the difference. And if we ever at any point, if we are less than, the difference is less than 0, that means this is wrong. The string representation of the tree is not a valid one, so we're gonna return false. Okay, and the second thing which we're gonna do is to check that that node is equal to that hash. If not, if it is not a null node, so if it is not equal to a hash, what we're gonna be doing is to like add 2 to the difference. This is because every node is gonna have two. Every non-null node is gonna have 2 out degrees. So that's why. So that's why we're gonna have we're gonna increase the difference by 2. And in the end we just need to check one thing. We wanted to make sure that the difference never goes below 0, and the last thing we wanted to do is was that if the difference is equal to 0. If the difference is equal to 0, that means it's a valid serialization of the binary tree. Node equals looking good. and it works.